This is the solution to Chapter 21, Problem 7 in the 9th edition. We have three particles on the x-axis. Particle 1, Particle 2, Particle 3. Particle 1 is fixed. Particle 2 is also fixed. Particle 3 is free to move along the x-axis. All of these particles are charged, but we're not told what the charge is on any of them. We're not even told which of the charges are positive and which are negative. So any of them could be positive, any of them could be negative. The distance between particles 1 and 2 is called L12. The distance between particles 2 and 3 is called L23. And we're told that if these two distances are the same, then there's no net force on particle 3. So in other words, it won't move when it's in that position. So what we want to know is the ratio of these two charges. Okay. Before we do any math at all, there are some things that we can determine. First of all, since the forces, the electrostatic forces from these two charges on this one have to cancel each other, and they're on the same side, then it means the signs of these two charges have to be opposite. For instance, if this one is attracting this one, then this one has to be repelling this one in order for them to subtract. If these were both attracting or they were both repelling, then the net force would not be 0. So that we know that they must have opposite signs in order for the forces to cancel out. Second, since Q2 is closer to Q3 and Q1 is farther away, if these two charges were equal in magnitude, then the force due to charge 2 would be much bigger than the force due to charge 1. So, in order for the charges to be equal, since this one is closer, then it must also have a lower charge. So since these are opposite and Q2 is less than Q1, then this tells us that Q1 over Q2 has to be something less than -1. So this we've determined before we've done any calculations at all. This should help our calculations. Okay, so if we look at what the electrostatic forces are between Q1 and Q3 and Q2 and Q3, just look at the magnitudes. The magnitude of this force is 1 over 4 pi epsilon naught times Q1 times Q3, and we can just put absolute values to line up because we only want the magnitude, over that distance squared. And from here, it's clear that L13 is this whole thing. So this is 1 over 4 pi epsilon naught Q1 Q3 over L12 plus L23 squared. Then, looking at the force between these two, similarly, 1 over 4 pi epsilon naught. Q2, Q3, again, we just compare about the magnitude over L23 squared. So if these two magnitudes equal, then that means the terms that they have in common, they all have both have a 1 over 4 pi epsilon naught, both have a Q3, so this means Q1 over L13 squared equals Q2 over L23 squared. And this is Q1 over L12 plus L23 squared. So, since we're finding Q1 over Q2, that means Q1 over Q2 equals L12 plus L23 squared over L23 squared. Now we're told that this is the situation that happens when these two are equal. So when these two are equal, this is 2L23 squared over L23 squared, which is 4. All right? As we said before, we didn't worry about the magnitudes in this case. We know the ratio has to be negative. We said it was less than -1. This is actually the magnitude of this. We can put magnitude signs on each of these to make this correct. So then, means Q1 over Q2 equals -4.